What is an isometric? A piping isometric drawing is a 3D representation of a piping system drawn on a 2D plane. Unlike a floor plan or an elevation drawing, an isometric drawing allows the viewer to see the length, width, and depth of a pipe in a single view. A piping isometric is a technical drawing that represents a three-dimensional piping system in a two-dimensional format. It is the primary document used by fabricators and installers because it provides a complete picture of the pipe's routing, dimensions, and materials in one single view. North arrow, crucial for orienting the pipe within the plant. Note that plant north might differ from magnetic north. The north arrow is the compass of a piping isometric drawing. Its main purpose is to orient the piping system within the physical space of the industrial plant. Without a north arrow, a fabricator or welder wouldn't know if a pipe should run toward the ocean, the road, or the neighboring tank. The north arrow is almost always placed in one of the top corners of the drawing. It typically points toward the upper right or upper left, aligning with one of the main 30-degree isometric axes. True north, geographic north, the actual direction toward the North Pole. Plant north, project north, a fictional north used by engineers to align with the plant's main structures, like a rectangular building or a fence line. In an isometric drawing, there are no horizontal lines. Everything is drawn on a grid with axes at 30 degrees to the horizontal. This is the central part of the drawing, shown in a 3D perspective, using 30 degrees axes. The 30 degrees rule is the fundamental geometric principle that allows a 3D piping system to be represented on a 2D sheet of paper without using perspective. It creates a distorted, but highly functional view where you can still use a ruler to measure distances. In a 2D drawing, you have X and Y. In an isometric, we simulate X, Y, and Z using these rules. Vertical lines. Stay 100% vertical. They represent elevation, up/down. Horizontal lines, north-south, are drawn at a $30°/circ angle to the horizontal baseline. Horizontal lines, east-west, are also drawn at a $30°/circ angle to the horizontal baseline, but in the opposite direction. This photo is final erection and welded as per example isometric. Bill of Materials, BOM. The Bill of Materials, BOM, in a piping isometric is essentially the shopping list or recipe for that specific line. It is a detailed table, usually located in the upper or right-hand corner of the drawing, that lists every single physical component required to fabricate and assemble the system shown. Without a BOM, an isometric is just a picture. With it, it becomes a construction document. Located usually on the right side or top corner, this is the shopping list for the fabrication shop. A standard BOM is divided into columns that provide specific technical data for each part. Item. A reference number that matches the bubbles on the drawing. Description. The full technical name, including type, schedule, and rating, technical specifications, e.g., pipe, seamless, ASTM A106 GRB. Size/NPS, the nominal pipe size of the component. Quantity, total length of pipe, in meters or feet, or the number of pieces for fittings and valves. Elevations and coordinates. In piping isometrics, elevations and coordinates are the GPS of your system. While the drawing shows you the shape of the pipe, the coordinates tell the installers exactly where that pipe sits in the real world, the 3D space of the plant. If you get these wrong, your pipe might end up trying to occupy the same space as a structural beam or another pipe, a nightmare called a clash. Most industrial plants use a grid system. Instead of X and Y, we use northings, N or S, the distance from a reference point, usually the plant's 0 point, along the north-south axis. Eastings, E or W, the distance along the east-west axis. How to read them. On an isometric, you will see callouts at every change of direction, elbows, T's, or branches. They usually look like this. N, 105,250. E, 200,400. Elevation, EL. Elevation represents the vertical height, Z-axis, relative to a reference level, usually sea level or a finished grade defined as 0.000. Centerline CL the most common. Coordinates are usually given to the exact center of the pipe. Bottom of pipe, BOP critical for pipe supports and drainage. If you are sitting a pipe on a steel beam, you need the BOP. Top of pipe, top often used for clearances or when a pipe needs to pass under an obstruction. Pro tip, in the field, always ask, is this elevation to the centerline or the bottom of pipe? A 24-inch pipe has a 12-inch difference between the two. Title block, the ID card of the document. Line number, the unique identifier for the piping system, essential for tracking. Project name, the specific plant or project site. Revision table, the history of changes to ensure you are working with the latest version. Continuations, references to the next drawing where the line continues, e.g. continued on ISO XXX. Let's to check this isometric. Here we can see the line discontinued that, in the context of a piping isometrics, show continuation isometric. In this case, show 1 equal T4 by 4. Then this solid line then represents the pipe within the isometric drawing with this flow direction. The item number 1 in bill of material is pipe stainless steel 316/316L, seamless. You also can see that diameter is 4-inch and schedule of pipe is 10s. Returning to isometric, if we continue with the information on the isometric drawing next item, we can see this box that represents the spool number 1, then 1 support. Others items that we can see in this isometric is the symbol that represents valve gate with number 12. Let's to see details in bill of material. Item number 12 is 1 gate valve flanged in material A351. Let's to check in top the diameter NPS of the valve. In this case, the diameter is 2-inch. We zoom in on the isometric view and see another important fitting. This symbol mean 1 flange with item number F4. Item number 4 is a flange type welding neck Skadul 40s and diameter 2-inch. Next fitting that we can see the symbol is 1 elbow with item number 2. The item number 2 is 1 elbow 90 degrees long radius with material 316/316L. Diameter 4 inches. Then we have this fitting 1 reducer T with size 4 by 2 inch. Dimensions. Distances between centerlines, fittings, or flange faces. Dimensioning between elbows, center to center. When dimensioning between 2 elbows, always measure from the intersection point of the vertical and horizontal centerlines. This is known as the center-to-center distance. Dimension of the reducing T. For a reducing T, we must specify the center-to-end distance for the run and the center-to-outlet distance for the branch. Dimensioning flanges. Center-to-face. Flanges are measured from the centerline of the pipe/fitting to the face of the flange.